Imagine staring up at the night sky on a clear evening, spotting that faint bright point in the southern hemisphere, Alpha Centauri. It looks so close, almost within reach. But what if I told you that journey to our nearest stellar neighbor isn't just hard? It's one of the most soul-crushing, terrifying tests humanity could ever face. Not because of monsters or aliens in the classic sense, but because of the crushing isolation, the decades of recycled air and recycled arguments, and the very real chance you die without ever stepping on solid ground again. Hey everyone, welcome back to Past Lives POV, where we dive deep into the frontiers of space, science, and what it really means to be human in this vast universe. Today, we're not just crunching numbers on light years, we're unpacking the raw, human reality of trying to reach Proxima Centauri. By the end, you'll see why this isn't sci-fi fantasy anymore, but a looming engineering, psychological, and philosophical nightmare. And why some of us would still sign up tomorrow. If you're as obsessed with the stars as I am, smash that like button and subscribe. We've got a lot of void to cross together. Let's launch into it. The Alpha Centauri system sits about 4.37 light-years away, with Proxima Centauri the closest of the trio at roughly 4.24 light-years. That's around 25 trillion miles. Proxima is a red dwarf, orbited by Proxima b, a rocky world discovered in 2016 that's roughly Earth-sized and sits in the habitable zone where liquid water might exist. Sounds promising, right? But as we'll see, getting there flips excitement into existential dread. In my own deep dives into space literature and simulations, I've realized something profound. Interstellar travel isn't about bigger rockets. It's about confronting how fragile we are as a species. Our fastest current probes, like the Parker Solar Probe hitting approximately 430,000 miles per hour, would still take millennia. To make it in a human lifetime, say 40 to 50 years one way, you need a significant fraction of light speed. That's where theory meets nightmare. Let's break down propulsion realistically, adding my take after poring over projects like Breakthrough Starshot. Chemical rockets? Laughably inadequate, they'd take over 100,000 years. Nuclear pulse, Project Orion style, detonating bombs behind a pusher plate, was studied seriously in the 1950s to 60s, but shelved for politics, radiation, and the sheer insanity of carrying thousands of nukes. Fusion drives promise efficiency using abundant hydrogen, but after 70-plus years, we're still chasing net positive energy on Earth, let alone a compact rocket. Antimatter? The ultimate energy release via E equals mc squared, but producing even grams would bankrupt nations and storing it without accidental annihilation. One glitch and boom, your ship becomes a new star. Ion drives and solar/laser sails are closer to reality. Starshot's concept, gigawatt lasers, pushing gram-scale probes with light sails to 20% light speed, could get data back in approximately 20 to 25 years for a flyby. But for crude, scale it up and you're wrestling the rocket equation. Every extra kilogram demands exponentially more fuel. My insight here, we're not just solving physics, we're solving economics and politics. International cooperation like the ISS, but on steroids, would be mandatory, yet with election cycles and short-term thinking, funding a multi-decade, trillion-dollar gamble feels improbable until Earth faces clear existential pressure, like worsening climate or resource wars. Picture this, not from a textbook, but inspired by real isolated missions that hint at the horror. Think of the Antarctic winter-over cruise at stations like Vostok or Concordia. For 9 months, 20 to 50 people are cut off, enduring minus 80 degrees Celsius darkness, recycled air, and the same faces. Real accounts describe winter-over syndrome, depression, irritability, hallucinations from sensory deprivation. One researcher I read about confessed to nearly losing it after months of the same hallway walks and recycled stories, mirroring what a 42-year starship would amplify by decades. Or take the Biosphere 2 experiment in the Arizona desert in the early 1990s. 8 people sealed in a closed ecosystem for 2 years to test self-sustaining habitats. They grew food hydroponically, recycled water, but faced crop failures, oxygen drops, interpersonal rifts that split the group into factions, and psychological strain so bad some still talk about the trauma today. Now, multiply that by 20 plus years in zero G, or spin-induced gravity, cosmic radiation, and the knowledge there's literally nowhere to run, no resupply, no evac. I once interviewed, hypothetically drawing from astronaut memoirs like those of Scott Kelly's year on the ISS, folks who've done long-duration spaceflight. Bone loss, muscle atrophy, vision issues from fluid shifts, even with daily exercise. On a starship, you'd need a rotating cylinder habitat, at least 100 to 200 meters radius to minimize Coriolis nausea. Imagine walking up a curved floor while the stars streak by outside. One wrong spin rate and everyone's dizzy and vomiting for weeks. Radiation is the silent killer. Without Earth's magnetosphere, cosmic rays would pepper DNA. Crews might see elevated cancers like submariners or Chernobyl liquidators faced, but over 40 years. Shielding with water tanks or regolith adds mass tyranny of the rocket equation again. Micrometeorites at relativistic speeds? A sand grain hits like TNT. You'd need layered Whipple shields or magnetic deflectors, but detection at 10% C leaves milliseconds to react. Life support, 93% plus water recycling like ISS, but pushed to near 100%. Algae or hydroponic farms for oxygen and veggies, mostly plants, maybe lab meat or fish tanks. After years, meals blur into monotony. Medical, a doctor or two, 3D printed meds, no full hospital. Aging crew, launch at 30, arrive at 70 plus, dealing with arthritis or dementia in confined quarters. Psychologically, it's a pressure cooker. Romances, breakups, power struggles in a 50 to 100 person crew. Children born en route. Ethical minefield, they never chose this metal world. Real parallel. Isolated groups in submarines show cliques forming, then conflict phases. On a starship, no escape hatch. Navigation. Stars move. You must lead the target, accounting for galactic orbits and relativity. Doppler shift, blue shifts, forward stars. A 0.1 degree error means missing by millions of miles. Communication lags grow to years. Your support from Earth becomes ancient history. By arrival, faster follow-on missions might have passed you. The weight calculation. Launch now and risk obsolescence, or wait and let someone else go first. Arrival at Proxima B. Tidally locked, one side eternal day scorching, one eternal night frozen, Terminator zone with hurricane winds. Flares from the red dwarf could strip atmosphere or irradiate the surface. It might have had ancient life, organic signatures possible, but now, harsh. Deceleration needs equal energy magnetic sails or starlight. Flyby only for probes means a glimpse, then eternal drift. The clear lesson? Interstellar travel forces us to redefine humanity, not as earthbound, but as a species willing to endure profound isolation for the chance to expand. It's terrifying because it strips illusions. We're small, vulnerable, but driven by curiosity that has carried us from savannas to the moon. The real victory isn't just arriving, it's becoming the kind of people who can thrive in the attempt. It teaches resilience, long-term thinking, and that our greatest adventures demand sacrifice. Would you go? Drop your answer in the comments. If this made you rethink our place in the cosmos, like, subscribe, and share. Next time you see Alpha Centauri, remember, it's not just distance, it's a mirror to our soul. Thanks for journeying with me. Dream big, stay curious, and reach for those stars. Good night.